And anybody else that has their test corrections, make sure you give it to me. Okay, we started yesterday talking about the binomial distribution. We said that before it's even a binomial, it's still, God bless you, it's still a probability distribution. It still meets two criteria. One, that the probabilities have to be between 0 and 1. And the second one, that the sum of all the probabilities have to equal 1. That has to be a given before it can even be considered to be a binomial. Then binomial says there are two possible outcomes. Bi meaning two. It has to meet these 4 criteria to be a binomial distribution. The first thing is it has to be repeated for a number of times. It has to say for 5 patients, for 6 days, 7 times. It has to have a fixed number of times. This is going to be your N. And each trial has to be independent. It cannot have any bearing or influence on any of the other trials. They have to be independent of each other. There only can be 2 possible outcomes, and we label them as a success or a failure. Now, yesterday we also said we could spin a spinner. And even though I have 4 things that can happen, if I want the probability of red, if I'm looking for how many times I can spin this and how many reds I will get, this will be my success, 1 out of 4, and my probability of not red, its complement, is considered my failure at 3 out of 4. That's my complement. So even though it has 4 choices, we can still do 2 outcomes, a success, a failure. The probability stays the same for each trial. In other words, if you have a replacement, it stays the same. If you do not replace, it can't be binomial because the probabilities are changing. And your random variable x just counts the number of successful trials, all your different outcomes in that event. And it usually goes from 0 to whatever the n is. And I gave you I put this on your note sheet as well. These are all like what we call these. N is the number of times, probability of success, probability of failure, and your random variable going from 0 to whatever n happens to be. Now, you did this in Algebra 2 as well. And you did it with that C formula. We're going to use that, and then we're going to use a calculator step to do this. The first thing we want to do is make sure that we can determine if, in fact, it is a binomial distribution. So if you take a look at the first 2 examples, they're just asking us to determine, is this a binomial distribution? So a certain surgical procedure has an 85% chance of success. A doctor performs this procedure on 8 patients. The random variable represents the number of successful surgeries. So first thing to do, lay out N, P, Q, and X, and then determine, does it meet all the criteria? What's N in this case? Huh? 8. It's being done on 8 patients. What's the probability of success? 85. We write that as 0.85. How do we get Q? Complement. Good. 1 minus 0.85. And X. Now, will either of these probabilities change with each surgery that we do? Do the probabilities stay fixed or do they change? They're fixed. Well, each surgery is independent of the one before it, right? Hopefully the doctor doesn't get worried. No, so each... overall, maybe, but each time he starts this, he has an 85% chance of success. And your X will go from 0 to 8. So is this binomial? Does this fit your binomial criteria? Yes. Each surgery is independent of the one before it. His probabilities are fixed. We do it n amount of times, 8. or your x value goes from 0 successes to 8 successes. Yes? Okay, now I'm going to erase this, and I'm going to use this same P and Q setup for the one below here. Down here. A jar contains 5 red marbles, 9 blue marbles, 6 green marbles. Altogether it has 20 marbles. You randomly select 3 marbles from the jar without replacement, and your random variable will represent the number of red marbles that you pull. How many times are you going to run this experiment? 3. I got to get 3 marbles. What's the probability of a red? 5 out of 20. Now, the next time I run this experiment, is it still 5 out of 20? The next time I go to pull a marble? No. What is it? 4 out of 19. And then the next time? 3 out of 18. Because it's without replacement. So this is not an independent trial. Each one depends on what happened before. Your probabilities are changing. So is this binomial? Is this a binomial experiment? No, because of this. If you don't replace, you change your probabilities. Your probabilities have to stay fixed. Right. The first time around, if you're going to pull out a red, your probability of getting a red is 5 out of 20. But you kept a marble in your hand. So now you have 4 reds and 19 marbles.
So if it's dependent, you can't get a binomial.
If it's a dependent one, it can't be binomial because your probabilities change. It can't be a binomial. It has to be completely independent each time. Like one of the more popular ones in Algebra 2 was, you go on vacation and the probability of rain is 30% every day. What is the probability that you go away for 6 days and it rains 3 days? God bless you. And it rains 3 days. Your probability is fixed for every day. Just because it rains every day doesn't change your probability. Okay. Alright, so now, you guys try this next one. Try this one. Take a minute and write down your answers and let's discuss them.
This one in our book.
It's in your book on page 202. We need to know if it makes all satisfies all 4 criteria of your binomial. So what is n in this case? 10. There are 10 questions. What is p? 0.25. Everybody get 0.25 or 1 out of 4? You have 4 possible answers. Only 1 is correct. 1 out of 4. So what is q? 75 or 3/4, either way. And what is x? 0 through 10. So does the probabilities change? No. They're constant. Each question is independent of the other. So do we have a binomial
Yeah.
experiment? Yes, we do. Good. So we need to make sure that it meets those criteria. Now, when we work your binomial, there's two ways we're going to do this. And either way is fine with me. This is the formula that you use in Algebra 2. It really doesn't look that bad. I wouldn't even write that one down because it's a lot simpler when we do it without using that. I don't like their formula, but this is the formula that they give. I'll do the formula with you, and then I'm going to show you how I do it with the calculator.
Said identify trial and experiment. What does that mean?
It's identify what?
Says identify trial and experiment.
A trial is, in the last one, a trial is answering the question. Yeah. Okay. Turn to example 2. We're going to work example 2 through using your... You don't have the 4.2 sheet? Does anybody else not have it? I gave it to you yesterday, didn't I?
Yeah.
203. Something like that. You don't have one? All right. A rotator cuff surgery has a 90% chance of success. The weird thing is, last year's book, well, 11 years ago to this year, they updated a lot of their examples, and they're using a lot more of ACL things, rotator, things that I guess happen to high school students as well. So you're going to see more of those things in there. Rotator cuff surgery has a 90% chance of success. The surgery is performed on 3 patients. Find the probability that the surgery is successful on exactly 2 patients. So let's see if it meets our binomial criteria. What's n? 3. It's done on 3 patients. What's the probability of success? 0.9. What's the probability of failure? 0.1. 1 minus 0.9. Somewhere. And S from 0 to 3. And we want to know exactly 2. Now, here's what you did in Algebra 2. Just watch the pattern. It's so much easier without their formulas. It doesn't matter what order your 2 patients come in. Combinations. We're going to do this 3 times. We want 2 successes. You always measure your success in life first. So your probability of success, 0.9, you want 2 of. Your probability of failure, you want 3 minus 2, 1. These exponents have to add up to n, because it tells us how many successes, how many failures we want, which has to add up to n, the total amount of times. The probability of success, always measure your success first, then your failure. Now, you can put this exactly in your calculator as it is. Exactly in your calculator. And you will get, what do you get for an answer? 0.243. Now, here's another way to do this. You have your calculators handy? Okay. Go to second VAERS. Remember you visited VAERS before? We visited second VAERS. So we're going to come down to second VAERS. And you're going to go all the way down till you see binomial PDF. This stands for probability distribution function. Not the C, the P. It's down like an A. It's down after the 0. Minus A. Now, trials. If you have the updated software, 3 trials. Probability of success, 0.9. The x value, what do we put in for the x value? Know how many do you want? 2. Paste. Do you see your answer? So, this is trials. N for trials. D for probability. X value. If you have the black calculators, or the ones that don't have the software on it, you have to put it in this way. N, P, X. Now look, these letters are in alphabetical order. N, P, X. The number of trials, the probability of success, which one you want. X. Second VARs. Make sure you use the PDF. PDF stands for probability distribution function. Now, you can do this either way. Paste. Paste just means, did you say paste? Yeah, paste just means hit paste. It'll paste it into the formula, the equation, and then you hit enter. It'll just paste it in and then say this is the format you want it in. Now, what we do in statistics is usually they'll say, what's the probability that there's 2 or more? What's the probability that there's less than 1? We make a table like this of all the possible x's, 0, 1, 2, 3, and the corresponding probabilities. Now, let me show you a little trick. You just did 2. You did the 2 one. Hit second, enter. Pull it back down, scroll over to the 2, and put in a 0. And hit enter. You just did the 0. It says 1, E, -3. What does the -3 mean? Move the 3 decimals 3 places to the left. So 0.001. Do you see it? Hit second enter again. What should I change? The 0 to a 1. Hit enter. 0.027. Hit second enter again. The only one we're missing is 3. Normally we can go through this and do it in order. 0.729. Add up all these probabilities for me. Quick, what is it? 1. Very good, Leslie. You're a quick adder. And Leslie knew it was 1 because all the sum of the probabilities have to equal 1. It has to fit a probability distribution function. All your probabilities are between 0 and 1.
Is that how you would check it?
Oh, you would check it, make sure you have them all right. Now, could you absolutely redo this using your C, 3, C, 0. I want 0 of them. 0.1, I want 3. Now, could you do second enter on this one? Yes. But you have to change this one, this one, this one each time. I could do it again. 3C, 1. 0.9, I want 1 of them. 0.1, I want 2 of them. This one, this one, this one. I could do this as many times as I need to. But the PDF is nice. Once you paste it, pull it down, and you'll get your whole table. So now, when in Algebra 2, when they said, what is the probability that it is less than 2, well, we know it's not 2, it's a 1 or 0. We just come here and we add those 2 probabilities together. It takes us all of 1 minute to set up that table. And then we add up our probabilities rather than say C30 plus 3C1. You see what I'm doing? And then add that together and then put that whole mess in your calculator. The C is a little more time consuming in your calculator. You gotta put the 3, the C, you gotta do these, you gotta make sure you get your exponents in there. Okay? Whichever way you like to do is fine with me. But the binomial PDF works nice. The CDF one is a cumulative distribution function. It's cumulative up to that point. Like if it's 5, excuse me, if it's like at most 5, it'll accumulate to the 5. But I don't really like to use the cumulative one because then kids accidentally use it rather than the right one, or they use it facing the wrong way. So I just takes all of another minute to put it in here. I think this is far easier for you to set your tables up. Now, you're going to try it too, with either method that you like to use. So I want to see you doing it and getting it to your paper. Bad, right? Okay. Now, what's confusing, guys, is finding your probability. And believe it or not, that's always the confusing part, finding your probability. How many times are you repeating this for? 5. Oops. Okay. What is it you're trying to pull? Club. So what is the probability of getting a club? 13 out of 52, 1 out of 4, 0.25. Can you leave it in a fraction? Absolutely. What is the probability of not a club? 39 out of 52, or 3/4, or 0.75. Okay. And how many do you exactly want? 3. Do you care what order those clubs come to you out of the 5 cards you pulled? You want them to have exactly 3. Do you care what order they're in? Could I get the first 3 clubs and then not, or the first one and the last one and the middle one? So that's where the combination comes in. So if you're doing your combination, the Bernoulli's theory, you have 5 to choose from. You want 3. Your probability of success, you want 3. Your probability of failure, you want what's left? 2. Now, if you're doing your binomial PDF, make sure you have the PDF one. Probability distribution function. Remember, it's in order. NPX. 5. Probability of success, 3. And then you hit enter. Okay. Okay. Let's set your table up. You can go from 0 clubs, 1 club, 2 clubs, 3 clubs, 4 clubs, 5 clubs, right? Now, which way did you set it up to, Mommy? Using the C? Okay, first time around, how did you set it up?
5.
Up, we want the 0?
Oh yeah, that's why I did all those 5 through 0. Right?
Okay, 5 through 0.
And then 425 with the 0.
0.
475.
Fifth. Okay.
That gives me like
0.227? 237? Okay, I want you to try this. I want you to go to second bears in your calc. Second bears. We're going to use second bears a lot. We already saw the PDF in here. We did the PDF one, the normal PDF. Come down till you see binomial PDF.
Yeah, I use that.
Okay,
And
hit
my
enter.
trials was 5.
Trials is 5.
425 and the value is 3.
Start at 0 though. Start at 0.
But I did the second enter thing like you were saying.
Okay.
And then I kept putting in like the 0 and stuff like that.
Okay, and what was wrong with it?
I don't know.
Wasn't getting it for you?
Yeah.
Second enter, just change the 0 to a 1.
Yeah, I got 0.37, then I got 0.396, 0.264, 0.088, 0.015, and 0.009.
Okay, what was wrong with that?
It didn't add up to 1.
What did it add up to?
Well, I rounded up, like, because you want 3
Yeah,
digits.
so what did it add up to?
Like 1.1259.
1259? That's probably too high. 396, let's just do this again. This is 0.264. This is 0.088. 4 is 0.015. Is one of these off on yours?
No, I did. Those are the numbers I just gave you.
Oh, this one. This e to the negative 4. Give me 3 decimals.
0, 0, 0. Yeah, that's exactly what I had.
That's exactly what you had?
Yeah,
1.0009. Something must have just went in wrong when you did the plus. Check your numbers first. Maybe you missed a decimal or 0 on one.
Exactly the same.
Yeah, I know, but check what you put in your calculator is what I'm saying. Let me just see what you added up. Oh, that's it right there. So there it is, right there. Okay, the reason, what is the reason that this didn't add up to 1 when we said this would? We rounded. We have some rounding issues in here. If we would let your calculator do them all, if you string them all out and let your calculator add them up, it will come out to 1. But they're irrational, and we had to stop in between and round it in between. Okay, so how does this look? It's nice, right? Okay. All right, I want to give you a couple to do. You're going to try a couple. Well, actually, we have 5 minutes, right?
Yeah.
All right. Hang on. Your hand broke? Really? Okay. This is what I want you to do. Not this part. I want you to do what I'll tell you in a minute. Page 210. I want you to do 11 and 12. Just 11 and 12. Page 210, 11 and 12. Okay, no. That has to get done now in the next 4 minutes. That has to get done now in the next 4 minutes. I'm not crazy. It's easy. Crazy? I am not.